We're going to look at a question which is appropriate for the WJEC Unit 4 Statistics module on the uniform distribution. The continuous uniform distribution. This question has a circle with a radius r, where r is a continuous random variable. This is uniformly distributed on the interval 0 to 5. So let's remind ourselves what this means. If r is the radius of the circle on the interval of 0 to 5, consider an interval of a to b which is uniformly distributed. This would mean that there is an equal probability of any of the events happening between a and b. So therefore, the total area underneath the graph of this function would be 1. This is a feature of all probability functions. The length, a to b, is b minus a, and therefore for the area to be 1, the height of the graph must be 1 over b minus a. Therefore, this gives us our probability density function, PDF. f of x is equal to 1 over b minus a, so long as x lies between a and b, and 0 if not. PDF is termed the probability distribution function or probability density function. It basically defines the probability the area underneath that graph will always be 1 for any PDF. For a uniform distribution, the mean and the variance are defined and given to us in the formula booklets. We will not use them in this question, but these are the relevant pieces of information to help with your revision. So back to the question. State the probability density function of r. We have an interval from 0 to 5, and therefore f of r is 1/5. The PDF is f of r is 1/5 if r is between 0 and 5 and is 0 otherwise. In part B, we're asked to find the probability that the area of a circle is greater than 25, where r is the radius. A is equal to pi r squared, and r is our random variable, which is uniformly distributed. The probability that a is greater than 25 is the probability that pi r squared is greater than 25. Divided by pi is the probability r squared is greater than 25 over pi. In this situation, this is equivalent to the probability that r is greater than the square root of 25 over pi, which is 5 over root pi. Of course, in the world of pure mathematics, we would be considering the negative root as well. However, r is a positive value. In this context, we'll only need to consider the positive. Now, to find the probability that r is greater than 5 over root pi, we realize that we can obtain this from the area under the graph between the value of 5 over root pi up to 5. This area is obtained by 5 minus 5 over root pi, that's the length, multiplied by 1/5, and that's the width. Multiplying these together gives us the area of the red section. That's the probability that the area is greater than 25, 0.4358.